In this video, we're going to take a look at confirming the answers that you have for the little bit of work that you had to do after reading section 7.1, the introduction to it. Chapter 7 is a neat section because we take a look, or would be taking a look, at conic sections. And conic sections you have already in your experience from geometry, have taken a look at circles, and in Algebra 2 you've taken a look at parabolas. A conic section is really a two-dimensional plane that intersects a double-naped cone, that two cones that are joined together at the vertex. And depending on how that two-dimensional plane intersects that double-naped cone will determine the conic section that results. And so the conic sections that we tend to investigate in this chapter 7 are first parabolas, then we move into circles. That's when that two-dimensional plane is parallel to the base of the cone, so it creates that circle. And when you give a slight little tilt to it, that circle then becomes distorted, if you will, and then into the shape of an ellipse. And then you have this example here when you generate a hyperbola, so that you can see you would have one curve, if you will, opening in an upward direction and another one in a downward direction. Notice that in all of the examples that are provided, that two-dimensional plane does not intersect the vertex of the cone. And when it does, what you end up with is a degenerate conic. And essentially, if you can envision that two-dimensional plane intersecting the double-naped cone at that vertex, you would end up creating a point, a line, or intersecting lines. So our focus is going to be on that definition of a parabola. And similar to when you think about geometry and when you were first introduced to circles, the definition of a circle would be the set of all points x, y in a plane that are equidistant from a fixed point being the center of the circle. So the definition of a parabola, very much defined in a similar fashion, is the set of all points x, y in a plane that are equidistant from a fixed line, our directrix, and a fixed point here called the focus. So that if we started to try to generate points, we would note maybe the easiest point right here would be this one. That would be the midpoint between the fixed point, the focus, and the directrix. And then from there, as you try to branch out and find other points that are equidistant, so in this case I'm envisioning maybe the shape of a square, and I would be able to reflect that same idea, trying to find that point. You can then think about drawing line segments, or if you will, creating an isosceles triangle. And about right there, that isosceles triangle would have this length, that distance, being the same as this length here, or this distance. And when you create enough points, you can see how the shape of a parabola is created. So also part of the reading is the standard equations of a parabola, and we are most used to this one right here, and that's because the x is being squared. So in some ways this reminds me of your vertex form of a parabola when you were first introduced to them back in Algebra 2. This is going to be called our standard equation of a parabola, especially as we start to deal with conics. And so whenever the x is being squared, that parabola is going to have a vertical axis of symmetry, or in other words, that parabola will either open up or open down. And when it opens up, the p is positive, and when it opens down, this value would be negative. When your y is being squared, our parabolas then go opening either to the right, or they would open to the left. And so if it opens to the right, this p-value would be positive, opening towards the positive direction, as just as it were if it were opening in an upward direction. Or if that p-value ends up being negative when the y is being squared, it will open up to the left. That p-value is called the directed distance from the vertex. So hopefully that makes sense. So the focus lies on the axis. So the focus should always lie on your axis of symmetry. P units from the vertex. So the focus is above the vertex. It is inside of the curve, if you will. And so right here is our HK. That is the vertex to the parabola. And if you were to think about that focus, if my graph were opening to the right, my focus would be again inside of the curve, moving in that positive direction. And likewise, again, when it's negative, it would be then moving down away from the vertex or to the left away from the vertex. And of course, if your vertex is the origin, these equations simplify nicely into those two. We normally look at the proof. The proof is for you in your book if you wanted to take advantage of that. So example 1, the answer that you should have gotten is the quantity of x minus 3 being squared equals 4, and then times the quantity of y minus 3. If you got that, and you also have the answer to example 2 part A, and so I'll quickly note those for you. That vertex should have been 0, 0. The focus should have been the ordered pair 0, 1. The directrix should have been the equation y equals a negative 1, and the axis of symmetry, so axis of symmetry, should have been the equation x equals 0. If you got those answers correct, feel free to fast forward to the next slide. For those of us that may not have gotten both of these correct, I will cover them at this time. I do tend to like to take a visual approach to these problems, and especially as you continue to learn about your other conics, it can be easy to maybe get some of your variables in the way they relate confused, so creating a picture can be helpful. Your job here is to find the equation in standard form of a parabola with a vertex 3, 3, and the directrix y equals 2, and the focus is 3, 4. So you might remind yourself that the vertex is given by HK. The directrix, so I went ahead and plotted that point over 3 and up 3. The directrix is this line right here. It is y equals 2. And the focus is this ordered pair 3, 4. So at that, I think one of the important things to note, what I gained from this picture, is that the p-value is a positive 1. And I also recognize that my graph would have to be opening in a vertical direction, specifically in an upward direction, given the location of my directrix and my focus. So at that, I then end up writing down the x minus h quantity squared equals 4p times the quantity y minus k equation. I recognize I do already have the h and the k, so you're able to fill in the 3 and the k value, and we just said p was 1, so this would be 4 times the quantity of y minus 3, and you can see that we have the correct answer. On to example 2, analyzing the conic section. So given this equation, we need to identify first, hopefully recognize maybe that it is a parabola because only the x is being squared. So when one of your variables, only one, is being squared, that indicates that you do have a parabola. I do take the time to rewrite it into the standard form, and at that I recognize with no quantity attached to the x, So nothing being subtracted from x and nothing being subtracted from y, I could first indicate that my vertex has to be the ordered pair 0, 0. Next, I want to figure out the p-value, and this is typically 4 times p times y. The p-value is a positive 1. So with my vertex at the origin, the p-value of positive 1, I recognize this is definitely opening in an upward direction, and the p-value of a positive 1 places the focus 1 unit above the vertex. Therefore, the focus has to be the ordered pair 0, 1. With the p-value being a 1, we would then move down 1 unit to y equals a negative 1, and at that we would be able to say that that has to be the directrix. And if you can remember from Algebra 2, your axis of symmetry, anytime your parabola is opening up or down, it is the x and the vertex. And so that axis of symmetry ends up being the equation x equals 0. On example 2, part B, you had to have that complete as well for this assignment, and those answers are the vertex is the ordered pair 0, 0. The focus would be 0, negative 2. The directrix y equals 2. And the axis of symmetry would be x equals 0. I'll walk you through if you did not get that correct. If you did, feel free to fast forward. So again, I would take the equation and rewrite it so it is in standard form, isolating the squared quantity. At that, I recognize then this should be written as x squared equals 4py, so that 4p is in the place of negative 8. And you can then recognize that p has to have the value of a negative 2. With the p of a negative 2 and the x being squared, I recognize that this is going to be a graph that opens in a downward direction. The vertex is 0, 0. The graph is opening in a downward direction. So that helps me to identify then my focus, and my focus would be over 0 and down 2. With that, the directrix must then be above it, and the directrix would be the equation y equals 2. And last but not least is the axis of symmetry, which would have to be x equals 0, because 0 is the x-coordinate of the vertex. On the last part of example 2, you have in front of you an equation, and it is not written in standard form. So if you're going to analyze the conic section, you will want to first place this into standard form. Because the y is being squared, our goal is to create the form y minus k quantity squared will be equal to 4p times the quantity of x minus h. So at that, I will isolate my y squared term and the negative 6y. I'll keep them together on this side of the equation, and I'll carry the other items over to the other side of the equal sign. So that would give me a 2x minus 11. And there are multiple ways that you can do this. But to make it so that you can consistently apply this approach as you continue on, I do tend to just like to bring this constant over. So your goal here is to complete the square. And if you can recall from Algebra 2, completing the square, you would always want to confirm that the coefficient in front of this squared term is a positive 1. And we currently have that. So with the a term being a positive 1, we look at the b value, negative 6. And remember, you're going to take the b value And let me change the color for you. We are going to take this b value, we will divide it by 2, and then we square it. This is the quantity that we will add to both sides. So negative 6 divided by 2 is a negative 3, and negative 3 squared is a positive 9. We will add 9 to both sides. This allows this now to be that perfect square trinomial so that we are able to factor it as a perfect square. And here we'll go ahead and get this to simplify to be 2x minus 2. Remember, our goal is to get this so that it is x and then plus or minus some quantity. So here we'll be factoring off the 2. Now that our equation is in standard form, we can go through and identify the vertex. Just be careful with the y being squared. Remember that it is opening sideways and that we sometimes fall into the habit of the hk with the h being first and writing the vertex as 3, 1 when the vertex is actually 1, 3. So just be careful as you work your way through these problems. With the vertex now being 1, 3, it's important to identify the p-value. So that 2, this constant right here, is where the 4p is, and that tells us that the p-value is 1/2. With a p-value of a positive 1/2, our graph is opening to the right. And if we were to identify this vertex point as the ordered pair 1, 3, moving to the right a half of a unit gives us our focus. So therefore, our focus should be 1.5, 3. And likewise, it gives us our directrix moving 1/2 of a unit to the left. Our directrix is going to be a vertical line, and that vertical line, subtracting 1/2 from that x value, would give us x equals 1/2. And lastly, that axis of symmetry, remember it's going to be this horizontal line that's coming through. That's now going to be the y in our vertex, and that gives us this equation, y equals 3. On this last example, we're going to take a look at creating the equation for the parabola given the following information. So if our vertex is -2, 0, and the focus is -6, 0, so quick little picture, here's -2, 0. The focus is here at -6, 0. It does tell me then it is opening this in this direction here to the left. So with that, it might be helpful as you're first learning how to create that standard equation to first write it out. And we do have our vertex, so this k value here would be a 0. So remember our vertex is h and k. So y minus 0, therefore it'll simplify nicely to this y squared, equals, and for now I'll just write 4p, and x minus a -2 is x plus 2. And that p-value is that directed distance. This is opening to the left. So you do want to make sure 1, 2, 3, 4, we have a -4 value for p. P is a -4. That gives us this answer here of y squared equals a -16 times this quantity of x plus 2. And our last example. Vertex is the ordered pair 0, 4. The directrix is this equation, y equals 2. So we know then that our parabola is opening in this upward direction. And so that has us using the other equation, the x minus h quantity squared, equaling 4p times this quantity of y minus k. Vertex, again, we have h and k, and this h value here is 0. So this left-hand side simplifies nicely to an x squared, 4p, and then y minus 4. And our job is to identify that p value. And we have the vertex, we have the directrix, so the p value must be a positive 2. Although we don't see it, the focus is located in here. Up here at 0, 6. So our equation does end up being x squared equals 4 times 2, which is 8, times this quantity of y minus 4.